This is the second part of our screencast about variables. So we'd been talking about confounding variables, and in the example, does playing Baby Mozart for your kids make them more likely to read above grade level in third grade? Two potential confounding variables or confounding factors are parental engagement, i.e. you have the time to play Baby Mozart for your kid, as the independent variable, might also impact the dependent variable of having time to read with them. Access to educational resources, so Baby Mozart, and also workbooks or pre-reading or reading exercises you might do with your children. Both of those things are confounders because they impact the independent variable and the dependent variable. Likewise, if we were looking at whether gender predicted interest in science, and we had some of those targeted STEM programs or science, technology, and math programs designed to get non-male children interested in science, gender would predict their attendance at one of the targeted STEM programs. And if the targeted STEM program is doing its job, might also predict a higher interest in science. So again, that program would impact both the dependent variable and the independent variable. So when we talk about variables, it's important to know that they can be defined and operationalized in different ways. And how you operationalize your variable will be dependent on what kind of statistical analysis you'll be doing with them. And we'll be talking about this in the second part of the semester when we look at statistical analyses. But for right now, I just want to go over a few kinds of variable types. And these have to do with how people can answer. So on a survey where people could check either yes or no, that question would be in that there's only two options. They're mutually exclusive. People select one or the other. Nominal variables are variables that include mutually exclusive categories, but there's no associated ranking. So, for example, we could have categories of species like zombie, human, sheep, elephant, capybara. And none of those are inherently better or worse than another. And there's no natural progression, like we start out as sheep, we become elephants, then we become zombies, then we become capybaras. They're just mutually exclusive categories with no ranking. Typically in research, categories like religion or national origin are operationalized as nominal variables. Ordinal variables are mutually exclusive categories that have some kind of ranking or order to them. So for example, levels in school, preschool, elementary school, middle school, junior high, high school would be ordinal variables because typically we begin in preschool and progress through the variables to high school. Continuous variables are a type of ordinal variable. They're also rank ordered and mutually exclusive. But with continuous variables, there's the same amount of difference between each variable. So rather than preschool, elementary school, middle school, which comprise different age ranges. You're in preschool for 2 to 3 years, but you're in elementary school for 6 or 7. So the interval in between those two categories is different. Whereas if we were talking about first grade, second grade, third grade, there's the same interval or amount of difference between each option. The difference between first grade and second grade is the same amount of difference as second grade and third grade. A ratio variable is a continuous variable that has a fixed 0 point. So number of children is usually a ratio variable because you can have 0 children, but you can't have less than 0 children. So now I want to talk about how we put variables into different formats. And as a content warning, for this slide, I'll be using an example related to domestic violence or sexual violence. So if you would like to skip this slide set, I will be on this slide for about 60 seconds or so you can just skip ahead to the next slide if you need to. So let's say we were doing some kind of survey where we were collecting data about domestic violence. We could set up our variables in many different ways. So we could have a dichotomous variable like, have you ever been abused? And people would answer yes or no. It would be a binary, two mutually exclusive categories that are opposites of each other. We could operationalize the variable about domestic violence as a nominal variable. So we could ask people if they've ever experienced any of the following categories: yelling, threats, coerced sexual contact. And we're not saying, and there's no rank or order to these. These are just different types of abuse or different categories that impact people differently and have different effects. We could operationalize domestic violence as a continuous variable by saying something like, on a scale of 1 to 10, with 1 being not at all and 10 being quite a lot, how much has your life been impacted by domestic violence? And that would give us a ranking. We could also operationalize it as a ratio variable by asking people, how many instances of domestic violence have you experienced? And that would start at 0, no instances, all the way through as many as people disclose to us. So we're looking at the same concept, but operationalizing it in many different ways. And again, this becomes important when we start talking about statistical analysis, in that different tests need different kinds of variables. So for example, let's say on the original survey, we had asked people a continuous variable. So on a scale of 1 to 10, how much has your life been impacted by domestic violence? That's a continuous variable. But some statistical tests are only possible if we have a dichotomous variable. So in that case, we would do something like take the first 2 notches on the scale to say if someone's life has only been impacted 1 or 2 on the scale, we're going to put them in the not abused group. If someone is 3 or higher, we're going to assume that they were impacted by domestic violence and put them in the yes group. And so that's fairly common in research, to play with variable types in order to make different analyses work. And again, we'll come back to this when we talk about statistics. So putting variables to use, once we've defined what we want to measure, oftentimes we need a way to do that. So we'll use what's called instruments or measurement tools. So things like surveys, interviews, various means of collecting data using instruments. And these instruments can be standardized or non-standardized. So standardized instruments are instruments that have already been developed and tested. So existing research has been used to come to a conclusion about how to measure concept, and scales have been developed, including screening or assessment tools, surveys, ways of asking questions that have been accepted. And oftentimes they've been what's called normed, which means they've been studied in different populations, so we know what to expect when used in various populations, what kind of the norm or standard answer or score is. Although it should be noted, too, that just because an instrument is standardized doesn't mean it's evidence-based. So there's several standardized instruments that are in practice right now that haven't been studied well. We don't have a definitive body of evidence around, but they're accepted as the standard of practice. So if you think back to our very first class when we talked about evidence-based interventions and the category of interventions that when I was training to be a midwife, my teacher was named Pat, and there were a whole bunch of things she did that weren't evidence-based, but I'd seen them work in practice. So there's a whole set of things I do called What Pat Did. And I think many standardized instruments also fall under the category of What Pat Did. We've used them a lot and they've become standardized, but they're not necessarily evidence-based. The other type of measurement tools is unstandardized measurements or instruments. And so these, just like it sounds, it's a measurement approach that hasn't been accepted in the literature yet. So it either hasn't been studied enough or it just hasn't been used enough. And unstandardized instruments are often about new concepts. or something that researchers are just starting to explore, though it's been around for a long time. Um, the textbook says that unstandardized instruments should be used as a last resort. I disagree with that, and I know many other researchers who also disagree with that, in that for several reasons. So my reason for disagreeing with the textbook is I think with standardized instruments, we have to look carefully at who gets to decide what's standardized, who gets to set the standards, who decides how we should be measuring a concept and who should be measuring a concept, what systems of power are at play. And then I think there's also the argument to be made, too, that many things in research depend on funding. And if we don't have funding to study a new concept, or a new to us concept, or a concept that's hard to get funded. So for me, I've always wanted to do a study about sexual violence among women with intellectual disabilities. It's very hard to get that study funded. And when I've done work related to that, it's often been using funding, finding a way to make it applicable to another project we already have funded. So along those lines, the funding stream sometimes will also dictate what we have standardized instruments around and what instruments are unstandardized. I also think it's important to look at not just how a concept is measured in the literature on a standardized instrument, but how people most impacted measure the concept. And that might be using an unstandardized but still valid instrument. So when using standardized instruments or standardized measures, the key here is uniformity. So we administer it the same way every time. It's scored the same way every time. We're using the same definition at all times. It's important to keep in mind, though, that measurement or how a concept is defined can vary a lot population to population. And so this is where it comes back to what's called norming, or establishing norms for a test. So for example, I worked on a study once where we were looking at a very specific way of measuring how much people knew about mammograms among older adults with intellectual and developmental disabilities. And so this test was normed to that population. We knew what the standard was in that population. Had I given the same measure to people who didn't have intellectual disabilities, we wouldn't have known what the standard score was. This also comes up sometimes with a translation of an instrument. So an instrument's developed in English, and then someone wants to use it among a Spanish-speaking population and translates it. And we start seeing really different results on the measure. It could be that the concept is different among people who don't speak English, or it could be that there's something subtle in the translation that means that the way that it's being heard or interpreted by speakers of Spanish is different than how it's heard or interpreted by speakers of English, meaning that the standardization isn't holding true across populations. So an example of a standardized instrument is the CAGE screener, which looks at drug and alcohol abuse with a series of 4 questions. So these questions are always asked using the exact same wording in the same way, and they're scored in the same way too. So if you answer yes to 2 questions, this will always be interpreted as a strong indication for substance abuse. Another example is the definition defining variables like intellectual disability. And so this is my field, and I can tell you that there's a lot of ongoing arguments that people are very passionate about how do we define this construct of intellectual disability. Do we look at IQ scores, which have been shown to be really kind of a bad measure that doesn't relate to someone's functional ability or what kind of supports they might need? Do we use the diagnosis code found in the ICD-9 or at this point the ICD-10? Do we use standardized testing? Do we evaluate someone's cognitive or functional abilities? Do we look at what supports they need? And so this is where your knowledge as clinicians and your clients' needs really come in. So you're relying on your clinical experience, your expertise, and your knowledge of your clients or what, they're saying about themselves, to pick the best option you can. And then use that option consistently as long as it applies to the population. It should be noted, too, that there's a branch of research focused on developing these instruments and really looking at how people define a construct like resiliency or intellectual disability. It's a really interesting branch of research, but it's not one we'll be talking about formally this semester, though, of course, if you want to learn more about it, please let me know. I'd be happy to talk to you. So here's an example of defining the variable of satisfaction with social services received. And this is an example where how we ask the questions and who asks them really, really matters. So for example, if I'm mandated to see you and you're assessing whether I should be, whether I should continue to be on parole, and you ask me how satisfied I am with your services, chances are I'm going to say very, very high, though that may or may not be how I'm actually feeling about these services I'm mandated to. So looking at those power relationships and figuring out ways to get information without putting anyone in danger is important, looking at defining variables. Social satisfaction with social services received is a really big concept, and sometimes asking that big question, are you satisfied with your clinical services? You might get a yes or a no, but you might be missing important elements of the picture. So oftentimes in a situation like this, we use what are called proxy measures. And proxy measures are things that we think speak to or get at the big question. So instead of saying, big picture, how satisfied are you? I might instead say, how long did you spend in the waiting room? Do you feel like the provider answered your questions and communicated with you well? Because the research has shown us that things like how long one spends in the waiting room and the quality of communication between a client and their provider are important to how satisfied people feel. So we look at all these different proxies or indicators that talk to us about satisfaction. So the last thing I want to talk about in this screencast is how do we know that a measure we're using is good? And to answer that question, there's two things we look at, validity and reliability. Validity is a way of looking at whether the measure we're using evaluates what it's supposed to evaluate, how accurate is the measure we're using. And then reliability looks at the consistency and the stability of the measure. So let's talk a little bit about validity first. So validity, again, it's looking at how accurate is this measure, how trustworthy is it? And there's various kinds of validity. The most basic one is what's called face validity, which is kind of eyeballing it and saying, okay, in this patient's satisfaction survey, we're asking about things like wait time, quality of communication, and cleanliness of the facility. On its surface, that makes sense. We can also look at criterion validity, which is when we know the answer. So we know, say for example, we already know that I'm undead. Does the measure confirm what we already know? So if I take a test measuring how likely I am to be a zombie, and we already know I'm a zombie, does the test results conform to what we already know? Two other kinds of validity that are similar to each other are content and construct validity. So construct validity looks at how well our test measures the construct or concept of zombiehood or satisfaction. Content validity looks at if we're measuring all the different elements that make up that construct. So in other words, content validity is looking at how well the variables that we've selected match the concept being measured and reflect the whole range of the concept. And then construct validity looks at how well we're capturing the construct that we're measuring. And both of them are just a way to evaluate if we are in fact measuring what we think we're measuring. So here's an example of the various types of validity using zombies. So face validity. On the surface, does it look right? Am I asking questions about brains, hauntings, things that you, just by eyeballing it, would associate with zombies? If I'm asking questions about, strawberries and favorite music, on its face, this might not be the best way of measuring zombiehood. Then we can look at content validity, which means, am I capturing all the elements of being a zombie that I should capture? So if my zombie measurement instrument only asked people about whether or not they ate brains and really focused on eating brains, that's one element of being a zombie. But maybe I'm leaving some things out. There's other elements of being a zombie, like, for example, fingers and toes falling off and traveling with a zombie crew. So if I was only looking at brain eating, the content validity of my instrument might be low. And this is a place where community-engaged research is really important. So if we're measuring patient satisfaction and we're defining it our way, rather than as it's defined in the community, we might get some things right, but we might some elements that are really important to the construct. We could look at criterion validity, which means, let's say, again, if we already know I'm a zombie, does scoring highly on the zombie scale predict what we already know? There's concurrent validity, which looks at, let's say there was already another instrument out there measuring zombiehood. We would expect that if my instrument has high validity, if you score high on my instrument, you would also score high on this other measure of zombiehood. And then finally, we could look at construct validity. Do the concepts I chose really represent zombiehood? In this instrument, do I have the construct of zombiehood down? And so the other way of evaluating an instrument is looking at reliability. And reliability, again, looks at the stability and consistency of the measure. And there's also various forms of reliability. So test-retest reliability looks at whether if I take the instrument today and then I take the instrument tomorrow, assuming that I haven't changed overnight and become undead, I will score the same today as I do tomorrow. That would be high test-retest reliability. There's what's called equivalent form validity, which is equivalent form reliability, which is related to concurrent validity. So both of them look at if the measure I'm using gets the same results as an existent measure. And with equivalent form reliability, it's really looking at over time and consistently. There's internal validity, which means that, let's say there were multiple questions on an instrument that measure the same construct. If there was high internal reliability, each question that got at the construct would be answered in the same way. Answers would agree with each other. And I'll give you an example of that in just a minute. The last kind of reliability is called inter-observer reliability. And that looks at if you and I both administered the measure to the same person, would we get the same results? And so looking at internal reliability, many surveys use more than one way of measuring a concept. So for example, if I was doing a survey about leisure activities, and one of the leisure activities was riding bikes, and I wanted to measure if you enjoy riding bikes, I might ask you directly, do you enjoy riding bikes? I might also ask, do you own a bike? Have you ridden a bike in the last year? Do you hate riding bikes? And if I have high internal reliability, you will answer all four of these questions in a way that indicate you like bikes. Here's something that we'll talk about a little bit more once we get into statistics. But for right now, all you need to know is that there's a mathematical test of reliability that gives you what's called a number that's called Cronbach's alpha. Cronbach's back was a researcher or mathematician who invented this. A Cronbach's alpha score is always a number between 0 and 1. And the closer the number is to 1, the more reliable the measure is. There's a formula that arrives at this that we're not going to get into in this course, but all you need to know is that if someone says the Cronbach's alpha is 0.6 or higher, the reliability of the instrument is acceptable. And if it's 0.8 or higher, so 0.8 is very close to 1, the test is reliable. And so in summary, whenever we measure anything, we need to think very, very carefully about what measurements we're using, why we're measuring it, how we'll measure it, how we'll operationalize and define the measure, and what's the justification for using this measurement choice as opposed to any other.